Hello everyone, in this video we are going to have a quick look at Java programming language. And why should we learn it? In our Introduction to Software Programming video, we saw Java is a high-level programming language. If you're pretty new to software development and want to know how a programming language is used, I strongly recommend you to watch our Software Programming Introduction video. I would like to highlight a couple of non-conventional reasons. Why is Java the right choice if you are looking to start your career as a software developer? Firstly, Java is mature. Why should I go for a mature language? In fact, the software industry itself has matured and have long ago adopted Agile methodology. Agile methodology helps the industry to deliver software as small chunks of features at much faster phase. Everyone wants quick delivery, resilient system, quick reaction time when there is an issue, overall, a quick turnaround in delivering applications. To meet all these industry needs, along with the core programming language, we need supporting tools and utilities to develop and deliver high-quality software applications. Java, being a mature language, has a lot of such supporting tools and utilities required at all phases of development to delivery, including design, development, testing, integration and delivery. So it is always wise to choose a mature language than a tender one, where you may have to deal with a lot of challenges due to lack of tools. I will introduce you all those tools used by professional software developers when we progress in this course. So stay tuned. Secondly, despite being a mature language, Java still evolves at faster phase to meet and adapt to the fast-changing industrial needs. Evolving and adapting are mandatory universal qualities for survival. Java is no exception. We as a developer going to invest a lot of time in learning a programming language, and it is imperative to choose the right language which will survive for longer period, justifying our effort put in learning. Another good reason to pick Java for building your career is Java has strong community support. Most of the longest surveying programming languages has strong active community support, and Java is best among them. More the people use a language, richer it becomes. The active communities will provide patterns to attack recurring issues, reusable application programming interfaces called APIs, and frameworks helping each other. With Java communities, you can find almost all common generic functionalities already built and available ready to use, so that you don't need to reinvent the wheel. You will see, we are self-using those API frameworks on need basis when we progress through this journey. Last but not least, Java is simple to learn. If you disagree, I strongly believe following this channel regularly will prove you wrong. Do I sound overconfident? Hope not. As a Java architect myself, I believe the above-mentioned points are the reasons why I still stick to Java and continue reading and practicing it. Now, let's see other conventional reasons why Java is praised for. Java is an object-oriented programming language. It supports automatic memory management. These features are best understood when we get hands-on in coding, so deferring it to later part of this tutorial. In addition, Java is platform independent. Java supports multithreading. And Java is backward compatible. Don't be worried if you don't know these concepts. Each of them deserves a separate explanation. And here we go. To understand what platform independent means and its advantages, first see what a platform is and why platform dependency is a problem. In our introduction video, we saw application software runs on operating system installed on hardware, and microprocessor is the one which executes our commands. Here, the OS and hardware combined together is called a platform. Do we have only one such platform available? The answer is no. When it comes to processors, there are two major players manufacturing microprocessors, one is Intel and the other is AMD. They both manufacture 32-bit and 64-bit architecture processors. There are multiple operating systems available in the market as well, like Microsoft Windows, Linux, Mac, etc. This leads to different combination of hardware plus operating system, resulting in multiple different platforms to deal with. You might be wondering, why should we worried about all these different platforms? The reason is, each of these platforms has its own machine language, and software developed for one platform will not run another. Let's do a small experiment. Here you see two consoles side by side. One on the left is Windows console and other is Linux one. Let me first try to print the OS version in Windows. The command I am using is vr and here is the result. OS name along with the version number. Let me try the same command in Linux. It's a disaster. The command vr is not supported in Linux. Let me try Linux specific command to get the version. Yes. Now I got the version. Let's try a different operation, say clear the console. I used the command clear in Linux and it has worked. Let's use the same command in Windows. It is not working, the command is not recognized. We need to use Windows specific command cls to get the job done. From this experiment, we learned that to perform the same operation in different platforms, we need to use different platform-specific commands. The same is applicable for the software running on those platforms. So applications developed in a platform-dependent language will work only in one platform where it is specifically developed for. It will not work in other platforms. So it is additional time and cost for industries to develop the same software again and again to support multiple platforms when they choose a platform-dependent language. There is a lot of redundancy. Java is lifesaver here. Being a platform-independent language, it supports the concept of write once and run anywhere. We just need to develop the software once. When we use Java, the application will behave the same irrespective of the platform where it is running. It's a common practice while using Java, where developers use Windows or Mac PCs to develop software and the developed software will go live in Linux servers and work the same as it ran on local machine without much drama. Let's see how platform independency is achieved in Java, for which we need to take a closer look into the Java compiler. Java compiler takes the Java program as input and generates bytecode as output, not the machine code directly as in other programming languages. What is this bytecode? Who is going to read it? Similar to machine-level language, bytecode is the language of JVM. JVM takes bytecode as input and translates them to underlying platform-specific machine language when we run the program. By this time, you might be wondering why do we have these two levels of translation. Java program to bytecode at compile time and bytecode to machine code at runtime. With these two levels of translation is how Java has achieved platform independency. Java takes care of developing platform-specific Java virtual machines, also called as Java Runtime Environment, JRE. There are other third-party JVM also available in the market. The input language of all of the JVMs are same, the bytecode. Hence, a compiled Java program can run in any of these platforms without any difference in behavior and the JVM takes care of the rest. We don't need to worry about the underlying platform. You can easily grasp this process when we develop and run our first Java program in the upcoming videos. Multithreading is the ability of a program to do multiple tasks concurrently. For instance, Let's assume you need to 4 letters and the average time taken to write a letter is 5 minutes. Without multitasking capability, we need to write these letters one after the other and it would take 20 minutes to complete all the letters. What if one can write all the 4 letters concurrently, like this professor in this video? Won't he finish all the 4 letters in 5 minutes? Yes, he will. What he is doing is called multithreading. The professor could have asked 3 more people to join him and would have finished those letters in 5 minutes. This way doing stuff is called multiprocessing. Doing so, he is using more resources than actual required. But he didn't. He is smart and utilized the existing resources to get the same performance. Java is also smart. It supports multithreading, helping us to effectively utilize the hardware resources and do things much faster than other programming languages. We saw Java evolves faster. So there will be more frequent releases of new versions of Java supporting new features. Java adds new capabilities in incremental fashion, without disrupting the existing features already supported in its previous versions. What does that mean for developers? You can seamlessly migrate to new version of Java without breaking your existing system, already developed using older version of Java. Suppose, if you have an application developed using Java 8, and now you want to add some new functionalities to your application by using some feature which is only available with some latest version of Java. You can easily do it by upgrading to latest version of Java and use those new features without breaking your existing application. This is possible only because Java is backward compatible. Suppose, if you have used some other backward incompatible programming language, your application will break when you migrate to newer version. So, either you need to rewrite your complete application using newer version, or you are stuck with the older version. Believe me guys, rewriting an entire application is not an easy task. A good programming language should not only evolve itself, but also let the applications developed using it to evolve easily. Won't Java remove any of its existing feature in their new version? They do it only when there is a real need of it. There are situations where some of the existing feature has some flaw like security loopholes, highly inefficient, or it encourages bad coding practices. Those such vulnerable features will obviously be removed in the newer version. What if we have already used those features in implementing a software? Can't we migrate to new version of Java? You can. Because Java follows two-step process in removing an existing feature. First, it deprecates those vulnerable features, warning the developers that the support for those APIs will be removed in future releases. Later, it will be removed permanently from subsequent releases. They don't remove it immediately. This gives enough buffer time for developers to refactor their code to get rid of deprecated APIs, still be able to migrate to newer versions of Java. We have come to the end of this video. I believe I've convinced with enough evidence and right reasons why to choose Java for developing applications. Please share your feedback in the comment section below and hit the subscribe button if you haven't done that already. I am not going to bore you guys anymore with theories. We are soon going to kickstart our coding. To start coding in Java, we need to install JDK first. We'll catch you back soon with a video on how to install JDK. Till that time, bye, from Yuva.